we heard from them an excellent idea about a product innovation, wherein how Lucas is going for a future technology in solid state batteries, and how Mr. Ramaswamy, out of his own, I would say, lifelong ambition, he developed Hans, then later went into the cleaning technology, and how he was able to convince Bosch, who really first shut the doors against him, and then later on voluntarily came forward to give him a technology. So they were talking about more of products. I would like to share about a technology, a process. At Super Auto Forge, we are innovative, and we sort of pioneered what is called as a cold forging in India. See, our chairman, Mr. Sitaraman, way back in 70s after his graduation, so he started a small turning industry to supply to companies like Lucas, TVS groups and all. Then while doing all the machining, he found we are wasting material. Why should we waste material? Why can't we do some innovation and sort of conserve the material? So out of that curiosity, without any technology, without any partnership with a foreign company, out of his own, lot of trial and error, we started the cold forging. Then the company, from 1975, we started cold forging, and that's the new technology. At that time in India, except for companies like Bosch or Telco, none of the private players had a cold forging. They all had only hot forging. So the cold forging technology, we had our own in-house trials, research, and then we went into it. And slowly we picked up the technology. And I would like to share with you as a company what we are doing now before we go into some of the innovations. Say, Super Auto Forge today, we are a 1,000 crore company. From a 1 crore company into way back in 1990, we are now 1,000 crore, and we export almost 80% of our products to OEMs. And we have we are also a tier 1 to global OEMs. And till now, we don't have a technology collaboration. And we have for all the couple of processes, and we have patents. And I would like to share one small instance wherein, like Mr. Ramaswamy, we also had a very, very interesting, I would say, instance. During early 90s, when Maruti and other companies came to India, till then we did not have the front wheel transmission technology. Everything was from the rear, we had a rear wheel driven. So when the front wheel drive came to India, the first company to start the manufacturing of CV joint is a company called GKN. So myself and our chairman, Mr. Sitaraman, we went to meet the director of the company, technical director, stating that because those products can only be cold forged. It cannot be done by, it can be done by machining, but it's a huge cost. And if you want to do manufacture in a mass production, cold forging is the only way. So we went and met them. Then incidentally, the technical director from Germany was there. So since we know that local person, he introduced the German director to us. He said, okay, he patiently listened to that. Then he said, okay, you are from down south. Then he said, you don't have in India, I don't think you'll be able to develop these products. He said, we have tried a couple of companies. We have tried even the TVS group, Sundaram Fasteners. They did not, they tried. We said, okay, give us a chance. Definitely we will try. So we made the first product. Then we went, we gave the samples to them, and then we started manufacturing mass production. And a couple of years later, I was there to meet for a meeting. Then the German director came down to the portico, and then he greeted me saying that as a company you have made what we have taken 20 years in Germany to do this. So that is the innovation part. Definitely today we are also innovating a lot of things with regard to the processes. And basically we are right now into aluminum forging. We are the first in India to do the aluminum both cold and also warm forging. We are the market leaders today. And we are also, I would like to say that we supply directly to a lot of OEMs, and we have a 0 ppm with them for the last 10 years. That would not have been possible but for the innovation. I would like to share with you a couple of this thing what we have innovated. Say one is we are not into many product lines. We are only into drive shafts, and then transmission segments, braking, and some suspension ball joints, and some defense sector. And in this, say one of the major, as a process, we do a lot of process innovation. Say traditionally, cold forging is done in presses. After each and every operation, the part is again annealed, and then we do a pass fading. It is done in 4 or 5 stages. When we went into mass production and exports, we found the need that we have to do mass production, and the process has to be lean. So we then work with technology called parts former. Say basically the multi-station headers are there to make a lot of fasteners or headed parts. So we looked at the possibility of using that technology and using parts former to make some of these auto components. We started our first work in the year 2006. That is when we bought the first parts former, which was almost 30 mm diameter, which is 6 station from a company called Nestrov from Europe. So basically, what used to take, this is a typical product, what used to take close to 10 days and almost wasting a lot of material, we were able to produce within 1 day at a speed of 70 pieces per minute. So that was the innovation. So even though some process were there for the parts former, adapting that process to the product was the key. And fortunately, we also had a good in-house tool room which is capable of making such tools, because the tools required for this are extremely critical. And if we are going to depend on outside sources, then your development time is also going to be more, and it's the technology cannot be, the IP and other problems will come. Another case study I would like to, this thing is about the, again, material. Say for the same product, customers were using a very different materials. So we had worked with customer right from the stage of design, and then we have gone for some micro alloy steels by which we were able to bring down the cost of material from a high cost nickel chromium steel. We were able to do a normal manganese plain carbon steel with a micro alloy. Thereby almost 6,000 to 7,000 rupees per ton we were able to save on this. In a mass production like this, it was a huge saving. And one more area is we have innovated a lot on the tooling. Say that today for the tooling technology, only Germans and Japanese, they are the leaders. So wherever, especially when you are making parts with such a high speed at 100 pieces a minute and all, you cannot use a normal tools. We have to go for carbide. So what we have done is we have gone for a sort of a duplex tools. in which we had the solid carbide only for the tip and then used plain HSS. That way, we were able to get a maximum tool life as well as the cost was less. Then this is the latest innovation what we have done is, say this is a specific product. In the new generation cars, we have all these rear braking. This also combines the parking brake and the rear brake. Say that it has got a very complex shape on the bottom, and it can be done only by a forging. Currently, most of our competitors abroad, they do it in a presses in multi-station. We started looking at a parts former. There is a multi-station horizontal machine by which this part can be done. So this, we were able to be successful, and we were also, because the tooling for that was very, very critical, and we had now employed 3D printing technology to make those toolings. Because such a complicated tooling, in fact, I am very happy that we are working with IIT Madras to develop, to really go into the details of the metallurgy and also the microstructure, because this tool, it is a composite tooling which we are developing with IIT Madras, and that has really proven well. And say similarly, mainly we have, as I told you, we have adapted a lot of boron tools. Similarly, one more major area where we have worked with customer on a concurrent engineering is, everywhere people are using for the CV joints, globally people were using a nickel and also molybdenum steel. Now today, with the availability of nickel and molybdenum being very scarce, we looked at a manganese chromium steel, which is cheaper, but it is difficult to forge. And then what we did was, we went into a new technology called, say basically right now, as Mr. T.K. Balaji said, we did not look at the current technology. We wanted to go for the future. So we went for what is called as a vacuum carburizing technology. Even though it is used in India by Delphi TVS and Fiat, there are the two users of vacuum technology for a limited application. We thought, why can't we use it for a mass production? And we worked with a German company called ALD. And today I'm happy to say, even though the equipment cost and the technology is very costly, when we did the mass production, our prices are much more competitive than a conventional SQF, and more than anything, it is a sustainable from the energy point of view. We don't use any oil for quenching. We use helium gas, which is also recycled. So practically there is no effluent, there is no soot, and it is a technology for the future. I'm happy to share with you that we were able to not only reduce the changeover from a moly steel, nickel-based moly steel to a manganese chromium steel, but using this technology, we were also able to put in place a more energy conserving, environmental friendly process. So this is really, in fact today, with our customers, we had a big problem in getting this. We spent almost 4 years to develop the process and get it accepted by global customers. And the moment we started it, one of our customers, he has started putting the same technology in his this thing, so that he is much more competitive. So that way, definitely today, innovation is the key. Whether it is a product or a process, innovation is a key. And we are also looking at a newer technology called cast forging. Say aluminum today is everywhere we are talking about lightweighting, and because of the e-vehicles, a lot of aluminum is going to be used. And the conventional way of aluminum is doing aluminum casting, but a complicated shapes cannot be forged. Now we are looking at a combination of a casting and forging, and we are working on that, and I am confident that we will be successful, and that will be a product process which will be a sustainable for future. So once again, I thank the audience for giving this opportunity. And I would like to end up saying innovation is the key. And if we don't innovate, we will only be stagnant here and we will not be competitive. Thank you.
Everybody talks about their success stories on innovation. Out of 5 innovations that you try, how many actually work out?
I would say 80% will work out.
80% will work.
You should have the patience. See, more than anything, it's a success rate. See, most of the people, what they do is they come up to 90%. And then at 90%, they give up. So the perseverance is what is important.
How long does it take, meaning in terms of years?
Say, for example, I was talking about this thing. It took us almost 3 years to convince the customer to go for this technology.
And it took Mr. Ramswamy 12 years.
Exactly. So you have to be persistent, otherwise you will not be able to succeed.